So in the last video, we were talking about nomenclature, and you were probably getting to a point where you're like, I got this, right? I'm doing pretty good. I mean, this doesn't seem too bad, does it? And then I throw you a curveball. And that curveball was, oh, by the way, do you remember those groups? Those groups like OH or NH2 or ROR, which was an ether, or the X for a halogen. Well, those can be on a molecule, and we're going to have to learn how to name those as well. So, what this means is that we play the same game that we've always played up until this point, but now we have modification of the rules. And those rules are going to change depending on what type of group that you have on that structure. So there's many different ways to name these structures. Like always, that's part of the problem with organic. And we're going to focus on two ways, which are the Iupac nomenclature and the common nomenclature system. And we're going to start with one group at a time. So the first group that we're going to start with are the alkyl halides. There's two ways to name an alkyl halide. So that means that I've got this molecule, ziggy-zaggedy, and then off of this molecule, I might have something like a Cl. Okay, there's a common way to name it, and there's an Iupac way to name it. Option 1 is the common name. The rules basically say, find the longest chain. Folks, that's what we've been doing. There's no difference here. But we're going to name the longest chain with a YL ending. And then what we do is we add the name of the halogen onto the end with an IDE ending. All right, so those are the rules for common names. Again, you'll see this maybe a little bit clearer when we actually do some example problems with it. Option number 2 is the Iupac, International Union of Pure and Applied Chemistry. Iupac basically says, find the longest carbon chain. Go figure, right? That seems to be the case with every single thing that we've done so far. And then the second step is we're going to have to tell you where the halogen is located. So this requires a number, like we've been doing in the past. And we typically name that halogen with an ORO. Fluoro, chloro, bromo, iodo. Right? Okay, so let's take a look at some examples. Here we go. So CH3Cl. We got to name it common. We have to name it systematic. Okay, so how do we do this? Well, let me flip to an actual sheet of paper. And that way we'll work these out together little bit by little bit. And we won't just rely on the textbook diagram. All right? So CH3Cl. All right, so common rules. Let's do that one first. Common rule said, name the longest carbon chain with a YL ending. So this would have been methane, because there's one carbon, right? Okay, well, the issue here is that ANE has to be erased because the directions tell me it needs to be a YL. So methyl. And then we name the halogen, which in this case is chlorine, but we drop that ending and we add an IDE. So this is going to be called methyl chloride. And this is the common name for that structure. Methyl chloride. Okay, well, Iupac. How do I Iupac it or provide the systematic name? Well, those rules are a little bit different. They're similar, but they're a little bit different. So the rules state, name the longest carbon chain, just like you've always done. Okay, so methane, because there's only one carbon in the longest chain there. And then on that one carbon, spot 1, I have a chloro group. So I can call this 1-chloromethane. Again, some people, they don't write the number there in front, and they will just call this chloromethane. There's only one option for that chlorine to go. That's it. Why do I need to designate a number? That's just how they see it, so they leave that off. Also, if it's just one substituent, and that's it, and there's no number for that one substituent, we assume that it's going to be 1 every single time. However, what I've told you in the past is still going to stay true here. Keep the 1, right? I mean, so what if it takes a few extra seconds to write down a 1? That's perfectly okay. That way you're safe. Okay, so there's one example of how to name these halogenated alkanes. Common name, methyl chloride. Iupac name, 1-chloromethane. All right, so let's do another example. In this example, CH3, CH2F. And we need to provide both names that this thing will go by. All right, so common name says find the longest carbon chain, which is 2, and you're going to name it as ethane. All right, however, it tells me to drop that ending, so I'm going to drop the ANE, and it says add YL, so this is ethyl. And F is going to stand for fluoride. Ethyl fluoride is going to be the common name for that structure. What about Iupac? Iupac says find the longest carbon chain, ethane, leave it like normal, like we always have. That's the way that we'll start it. And then on spot number 1, because that's closest to the end out here, I have a fluoro group. 1-fluoroethane is going to be the Iupac name of that molecule. Again, you can leave the 1 off if it makes you happy. I mean, I'm not going to be a judge, okay? That's perfectly okay with me if you're okay with it. All right, let's look at another. CH3, CH, CH3, and then here, let's put an I. So we have to give a common name, and we have to give an Iupac. I'm going to start with this one with Iupac first. All right, Iupac, 3 carbons in total. All right, so this is normally a propane. And then on carbon number 2, I have an iodo. Folks, that's all there is to it. 2-iodopropane. That is the Iupac name for the structure. Now, what about common? All right, longest carbon chain here is prop, but I can't really use like this stuff, 2s and 3s and 4s. I mean, that's really designated for Iupac here. So is there a common name? Sometimes there's not. You just got to be careful. And I try to be really good about it. I try to be really good. If there is a common name, I try to tell you, give me common name and Iupac name. If I just say give me the name, then I'm just assuming that you're probably going to give me Iupac for the name of that molecule. But this does have a common name. And I can probably get across the common name a little bit better if I draw this a different way. CH3, CH with an I, and here we have a kink of a CH3. Notice this I is in the middle, okay? This I is in the middle of this longest carbon chain, and here if I give you this kink with the I still in the middle, I think that you would tell me that this would be called the iso unit, right? So this is isopropyl, and then I add the ion for iodide. Isopropyl iodide. Okay, so there's the Iupac name, and there's the common name for that structure. Let's do another one. CH3, CH2, CH, CH3, and in here we have a Br. So I've got an Iupac, and I also have a common name for this one. All right, so let's start with Iupac first. Longest carbon chain is 4, right? 1, 2, 3, 4, all the way across. 4 is going to be butane. Which way do I number? I start here, 1, 2, 3, 4. It's closest to the end with the Br. My Br gets the lowest number if I start on that side. So at carbon number 2, I have a bromo. 2-bromobutane. That's the Iupac name for that molecule. Okay? Again, very similar to what we've been doing in the past. The common name here, though, is a little bit strange. The common name, I could rewrite this. Maybe you'll see it a little bit better if I do this. Again, it's a kink, but it's not a true L, so it's not an iso unit. This bromo is attached to a secondary carbon. This secondary carbon has a carbon to the left and a carbon down below, so it's connected to two others, which is why it's a secondary carbon. So we can call this sec-butyl. This is a sec-butyl group. And what is it a sec-butyl of? It's a sec-butyl bromide. So there's the Iupac, and there's the common name for that structure. Again, we really place a focus on Iupac whenever we can, but I want you to understand and accept the fact that common names are still out there. And again, we put the blame on the old school people that still use those common names over the Iupac names. All right? Okay, so there's the story, or part of a story, about how we can name these chlorinated, halogenated, fluorinated, brominated, iodonated, if that's a word, molecules. Okay, so that's the way that we would name these structures. Now, let's get away from some of the common names. They're always a problem, okay? And this time we're going to name bigger molecules that don't really have a common name, and we're going to stick to the Iupac nomenclature system. All right, so let's do an example. We'll do CH3, CH2, CH with a CH3 that points up, and then we'll do CH2, CH2, CH with a BR that points down, and then a CH3. So the directions tell me provide a name. Okay, provide a name. So the Iupac name is what they're wanting me to provide. It's assumed if it just says provide the name. And I need to find the longest carbon chain in order to do it. All right, so my longest carbon chain here, 1, 2, 3, 4, 5, 6, 7. There's no way that I can beat out a 7. It's going to be 7, folks. All right. So because of that, this is a heptane. Now, I've got to figure out how to number. I see that this is my longest carbon chain, so I'll circle it. And I'm going to have to name this group up here, which I know is a methyl group. And I have to name this group here, which is a bromo group. And I have to put all this information together. Well, alphabetical order, I know that B, bromo, comes before M, which is methyl. So there we go. Just putting the pieces together. That's all I'm doing. Taking baby steps. It's okay. And now the numbering system is going to come into play. I could number from the left to the right, or I could number from the right to the left. I try to gravitate toward the side that has the most substituents on it. And it looks like one of them is over here on the right-hand side. One is making its way over to the left-hand side. But the rule of the game is to choose numbers that give me the lowest number possible. So up here, I'll just number left to right. 1, 2, 3, 4, 5, 6, 7. And then down below, I'll number the opposite way. 1, 2, 3, 4, 5, 6, 7. Now we got to figure out which way gives me the lowest numbers. If I go left to right, my spot is at 3 and at 6. If I go right to left, my spot will be at 2 and 5. That is the lowest number possible. So at spot number 2, I have a bromo. And then at spot number 5, I have a methyl. So the name of the structure is 2-bromo, 5-methyl heptane. And that is the Iupac name for that compound. All right. This needs to be squeezed in a little bit more. I just wrote it a little bit bigger so that way I could separate the pieces and parts for you. But it is written kind of almost as one word. Again, I'm not really particular about that, but that is what you would see in the text, and that's also what you would see in things like Blackboard as well. They don't put the extra space in there. I do it for me, but the textbook is not going to do it at all. Okay? All right, so let's do another example of those. Let's do CH3, carbon, with a CH3 that points up, a CH3 that points down, a CH2, a CH2, 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 and Cl. Oh. Okay. So the name of the game. Find the longest carbon chain. 1, 2, 3, 4, 5, 6. 6 carbons in a row. Don't let this one throw you off. That's not a carbon. That's a chlorine. So don't count the C of chlorine because we only count carbons for the longest chain. In addition to that, 1, 2, 3, 4, 5, I can go up to get 6. I can go down to get 6. I can go to the left to get 6. Doesn't really matter. 6 is going to be the longest one. So I'm just going to circle this to let you know that that is my parent chain. So 6 carbons in total. This is called a hexane. Well, I've got a chloro group that is on this molecule. And here I have a methyl group. And here I have a methyl group. So these two things are going to come together to give me a dimethyl, because there's 2 of them. And it also looks like chloro would actually be written first because C comes before M. And then I have this dimethyl group. Now we got to figure out numbers. Where are they going to be located? Well, once more, I've got an option to go left to right or right to left. And you're going to tell me, it looks like the majority of the substituents are over here to the left-hand side. So I'm going to start here with carbon number 1, and I'm going to call this carbon number 2. That's wrong. What? You're changing the rules on me? Well, not really. Because that rule is still in place. If all you have are alkyl groups, right? All carbons and hydrogens. You do number closest to the side that has the most. But here we have a mixture of groups. We have alkyl groups, a methyl and a methyl, and we also have a halogen group as well. That's a little different. We've not really seen that before in some of our other examples. And for that reason, we give it preference. We give it priority. So if there's just alkyl groups and nothing more that we have to name, like methyls or ethyls or propyls or butyls, then we do number closest to the side that has the most of them. But then when we start mixing in these other groups, like a halogen in this case, and we compare that against the alkyl groups, the halogen will take priority because it's a little different. It's a little special. We don't see it that often, maybe, right? It stands out from the crowd. And because of that reason, we actually will, by default, start numbering closest to the halogen group. So halogen is going to be written above an alkyl. We give it preference whenever we see it. So that will be carbon number 1, which means down here, that will be a 1-chloro. And then carbon 2, then carbon 3, then carbon 4, then carbon 5. And at carbon number 5, I have a methyl. And on carbon number 5, I have another methyl. So this is a 5,5 dimethyl hexane. Folks, I told you, the water's going to get a little dirty. But we got to play the game. And you got to learn how to play the game. And sometimes these little rules will gradually switch and change as we begin to learn more and more technique in the nomenclature system, because once more we set a foundation, find the longest carbon chain, name the alkyl groups, put numbers on them, you got it. And then we throw in an extra little curveball with a halogen in this case, and we say, oh, by the way, an extra little rule comes in, and this rule is going to give preference to the halogen wherever it shows up. That's kind of where we would want to start talking about it. Okay? All right, let's do another example. This one will have a ring. There we go. 5-membered ring. And we have an I, and we have a CH2, CH3. Okay, so with this example, my longest carbon chain, right there. So this is a cyclo, because it's a ring, and there's 5 carbons, so it's a pentane, cyclopentane. The I is called iodo, and this CH2CH3, that's going to be called ethyl. Okay, so there's actually a mistake in your text. I mean, this is actually in your textbook. If you do not find it in your textbook, good, because you shouldn't see it in your textbook because it's wrong. They actually do name this a little backward. Leave that to a graduate student. Graduate students miss that. They just let it go to print. So just like before, we have a halogen, I, and we have an alkyl group, ethyl. So because the I is a little special, and because this is a ring, how do we number this? 1, 2, or 1, 2? Well, this carbon will get the 1 spot, and this one will get a 2 spot. I want to give preference to the halogens whenever they show up. Okay, so what that means is that alphabetizing, E comes before I. So I would want to write down ethyl, and then I would want to write down iodo. At spot number 1, I see the iodo, and at spot number 2, I see the ethyl group. So the proper name of this compound needs to be 2-ethyl, 1-iodo, cyclopentane. All right, let's do another one. Again, examples are going to be your best friend. You'll love them. Okay, so here we have another ring. It's a 6-membered ring. And here we've got a bromo group. Here we'll have a chloro group. And here we'll have a methyl group. Methyl, bromo, chloro. Okay. So we need to find the longest carbon chain. Longest carbon chain is the 6-membered ring that's right there in the center, and that 6-membered ring is called a cyclohexane. Ta-da! So I want to write down these substituents in alphabetical order. I mean, I know that that's going to have to be a thing. I might as well get used to that. So B comes first, so bromo. And then C comes next, so that would be chloro. And then the M, which would be your methyl group. All right, so I just wrote them in alphabetical order, and now I need to determine the numbering. I need to figure out what location are they on. So I kept saying halogens really take the priority here. We really like to give priority on the halogens whenever we can. And we want to number closest to the side that has those halogens. Well, the problem here is that I've got a halogen up here, and then I got a halogen that's down here below. It also looks like there's 2 substituents. There's one on this end and one on this end. So if I have to number them and give me a lower group number whenever possible, then I would want to number on this side. This is where I would want to be. So here are the options for you. I know that you're going to take the rules and you're going to apply those rules, and you're going to say, all right, a number on the bottom side, because that's where most of them are. And this would be group number 1, because this is the halogen, and that gives priority. And then this is going to be maybe group number 2, because it is on this side. Well, when you do that, you're going to default it. And it's going to go 1, 2, this is going to be 3, this is going to be 4, and this is going to be 5, and that will be carbon 6. Okay, so there is one option for you to do that. Another option that you might look at when you do this is say, here's carbon number 1, but this is a halogen up here at the top. So if we're giving priority to halogens, then why don't we go this way? 2, 3, 4, 5, and 6. Okay, well, jot down the numbers over here to the left. Remember the name of the game, lowest group number possible. So in this particular case, the second version, I have a group number of a 1, I have a group number of a 3, and I have a group number of a 6. 1 is chloro, 3 is the bromo, 6 is the methyl. In the first round that we did, chloro was at spot 1, methyl was at spot 2, and then bromo was at spot 5. Now compare these. Out of these two choices that you've done so far, which one's better? And I hope that you would look at the one in black, because that gives me the lower numbers, 1, 2s, and 5s. All right, so that means that this purple option, this is a worse option for me. So I'm going to erase it. Right now, the black version actually suited me a little bit better. But that's not the only way that we can number this ring. There's another way. Over here, the chloro and the methyl group are kind of grouped together. And I know that I told you that we give halogens the priority whenever we can. All right, and that's exactly what we do. But for this particular case, we have a methyl group that is spot 1. Chloro could be spot 2. 3 and 4 would be my bromo. And here I have a 1, a 2, and a 4. This numbering system beats out that numbering system because 4 is a lower number than a 5. So just because of the way that this shape is structured, we do not go by that defaulted rule that we talked about just a few seconds ago about giving halogens the priority. We are over here, we are looking at this chlorine and we're saying this is special. We want to kind of name it over here on this side. But just because the way this is ordered, my numbering can become a little bit better if I start the numbering at the methyl group and not at the chloro group. And the numbering system here kind of trumps out some of that other stuff. So at spot 1, this is my methyl group. And then at spot number 2, I have a chloro group. And then at spot number 4, I have a bromo group. And that is the reason that it is numbered that way. We know that that halogen is not ranked number 1. No one said that. No one said we had to rank it number 1, but we said that we give it priority. You know, if given an option, we go to that site and we do give it a number 1, and then we number everything else accordingly. But in the ring systems, funny things begin to happen, and that's, in this example, is the reason that the methyl group is ranked at number 1. So this gives me the lower numbers all the way around. That is what Iupac really prefers, but we are still going on the side that has the most substituents. All right. Okay. So that's where I'll stop this video. I know it seems like an exception. I know that when the going gets good, it seems like I'm throwing something else at you, and now the rules slightly modify or slightly change a little bit. But once again, the more of these that you do, the more comfortable that you're going to get. And that's why in the next video, we'll continue to do more examples. So stay tuned. Don't take a break. I'm coming for you, or you need to come for me and demand more examples. In the next video, I'll give them to you.